So here's your site, guys. And this is just a random design that I picked from I don't know where or when. And not a bad design, kind of fun. Some of the things you need to be looking at on this right off the bat is, where are the slopes? Let me pull my thing down here where I can see it. Where are the slopes currently going? Where are the really steep slopes? That's slopes coming a little bit towards us, which might be interesting. So we're going to reiterate that. This slope is kind of going down this direction. That's all fine and good. When you are doing this, you need to start looking at where are the current contours and are there any patterns in those current contours. So for example, if I follow this one around, it kind of does that. And I'll just pick another one. It kind of does this. And I'm just going to pick another one down here. It kind of, well, I'm not sure where it goes down there, but then it kind of comes back up here like this. And then we kind of have the same thing happening. It gets up in closer here, to be truthful, like that. And this one actually probably comes up that way. What I want to point out to you is that that means that if I was going to start laying out contours on this site, I'd be thinking about this, and I'd be thinking about this. You see what I'm saying? I see the natural pattern of the contours, and I'm going to start thinking immediately about how can I make use of those natural patterns. So it would not be unusual to have a V-shaped solution to this. So that's the first point I want to make to you. Then the second point I want to make to you is about where we have ridge lines. So if I look at this, there is a major ridge line running across this site. There are minor ridge lines as well as major ridge lines. And the way we figure those out is you just kind of play around with this a little bit. You can see that there's a ridge here. You can see that there's a ridge here. You can see that there's a ridge here. You can see, looking at the contours, that there is some sort of a ridge here. Does that make sense? It is always preferable to make your life easy. Not always possible, but always preferable if you can take advantage of a ridge line for your building. And we're going to go back to the previous slide for just a second to talk about why that is. There we go. Because you know that based upon things that we've already talked about, you're going to want a swale adjacent to this building. And where are you going to want that swale adjacent to the building? Well, it might be that you want one down the side, but most importantly, you want one across the top. So that swale across the top is critically important because you've got water running towards the building right now in this design. And we want to divert that water around. So the ability to have a swale that goes away from the building on the uphill side that divides the water is something you're going to have in every single design. It might be a semi-symmetric swale. It might not. It might be that that swale is, a great big, arrow going this way and a little bit of arrow going that way. That's fine. Sometimes you have a swale that runs all the way across the front of the building and just a little bit on the other side. That's acceptable as well. but you are going to have something to divert water away from the building. So when I then go back and look at the next page, you can see that this particular ridge line that happens to hit the building is going to be very useful. So I'm going to reiterate that. This ridge line is intersecting the building. That makes life easy for you. And making life easy at this stage in your life is part of what we want to do. So if it is intersecting there, then having a swale running off above that is going to be much simpler. Because frankly, if you look at the water as it's flowing right now, it's kind of flowing off in these directions. Now, granted, this one's coming towards you, but then it kind of goes down here. So you can see that having a big swale that goes here in front of your building is something you're all going to have to do. So by looking at that ridge line first, I have an idea. Now, is that the only place I could put a ridge line? No. But I have taken the major portions of the site here, thinking, all right, I've got stuff that runs this way, I've got stuff that runs that way, and I've got stuff here doing something like that, and there doing something like this. And so I'm purposely trying to take advantage of that. If there was a natural ridge line that ran this way, I am perfectly within my rights as a designer to say, you know, we are going to take that and we're going to shift it over here. Does that make sense? You are perfectly fine shifting the ridge line if you're on a fairly flat area. And of course, you're working on something that has about a 2% slope naturally. So that works out just fine. The next point we want to make is we talked about 50-foot offsets. And what I've done here is I've shown lines that I've offset. Now, I could offset those in AutoCAD. I could do slight measurements and copy them in Photoshop, any of the Adobe things. I know that if I had a piece of pavement aligned with that, let's say we had, this was the direction of the flow, that would be a 2% slope, and that would be perfectly acceptable. If I split it on the ridge and had another 2% slope running in this direction, that would also be perfectly acceptable. Do you understand that part of the concept? Because it's going to get a little more complicated. These green lines that are offset 50 feet represent how far apart contours would need to be on a 2% slope. That's what this is about. How you put those green lines on is totally up to you in your different programs. You can do it by hand on paper. You can do it in AutoCAD if you must. If you do it in AutoCAD, please transfer it over to something else so you can actually start doing some sketching. So we start with that idea, and then we can actually put another one in. So now what I'm looking at two grids. Those two grids represent options that I have. And you don't need to worry about them yet, because what's going to happen is we're going to rotate those grids. So I just rotated them. And you might be saying, well, why'd you rotate them that way? Okay, let's remember when I was back here, I said that there were natural pattern of contours. And so what I want to do is I want to rotate that grid to line up with those natural patterns of contours. Now, is this the only way we can line them up? No. But if we did line them up with this, what we can do is we can actually say, all right, this could be a pattern for our pavement. Now that was a big jump. Do you guys agree? Most of you should be saying, say what? So let's go back and look at this. I can choose now to use these contours, and I'm not even worried about what their number is yet. But I'm going to say if this is a ridge line going through here, okay, I could simply say that when this contour hits the ridge line, I'm going to now bend that contour back this way. When this contour hits the ridge line, I'm going to bend that contour back this way. When this contour hits the ridge line, I'm going to bend that contour back this way. So this pattern going across the entire site represents a 2% slope running this direction and this direction. That pattern is the way I could drain this parking lot. I can continue that pattern down to here. But at some point, I'm going to want to have a reverse. I'm going to show you what I mean by a reverse. I might come to this point and then go back that way with it. And then, of course, I could do the same with this. What that means, and this is where it gets confusing when you first start doing this, is I've got a slope running this direction, and I've got a slope running this direction. And in the middle of all that, I've got a swale running this direction. I, of course, can also reverse it on the other side as well. And now I've got a slope running this direction, a slope running this direction away from the building, and a swale running this direction. Now, I need to know if you guys understand this, because this is critical. What I did is I laid out lines 50 feet apart, which represent a 2% slope. You can lay them out 40 feet apart, 2.5% slope, perfectly acceptable. And then I rotated those lines to make them fit better with my site. So what I'm doing here is I am pushing contours just like I did before, but I'm doing it in a rectilinear manner, if you will. In other words, remember on our previous on that puppy, we said to ourselves, all right, we are going to lay contours across this paved surface. Okay, you see that? That wasn't complicated. That made sense to everybody. Now we're going to say, let's do the same thing on this site. And we're going to zoom back up to show you conceptually what we're doing here. Because what we're doing is we're saying, all right, let's lay contours across this site. So just like we did this for the small parking lot in the previous drawing, we're going to do the same thing on this parking lot. Does that make it easier to understand? So we're going from the previous idea of laying the contours across the parking lot that we did in the small parking lot, and now we're doing the exact same thing in the large parking lot. The difference is we have a clear ridge line here. This is certainly not the only way we could lay these contours. Now we could have just said, we're just going to, lay them across this way. Right? We could have done it just like that and said, all right, we're going to put these in here. They're going to be about 50 feet apart, and we're draining everything towards the building. And then when we get down to the building, wow, we better have a swale of some sort. And that way we wind up with a swale going off on both sides. You see how that could work? That means that we have a 2% slope going this direction. We have a 2% slope going this direction. And then we have a swale. You with me? So all we're doing now is we're saying, all right, Stuart, that's what happens if we run them straight across. What would happen if we ran them long? What would happen if we tilted them so they ran this way? In fact, maybe we want to tilt them back even more. Maybe we want to tilt them back, that far, or maybe this far. And please note, the slope does not have to match on both sides of the parking lot. So as I've drawn this just now, the slope on the upper side is steeper than the slope on the lower side, because the contour lines on the upper side are closer together than the contour lines on the lower side. But they still work. And of course, I could then come back in when I get next to my building and say, all right, I'm actually going to change the size of that. That's what I'm going to do. I could actually reverse these contours at this point, and I now have a swale that's running away from the building on the uphill side in both directions. So this is where we're trying to get to. One of the ways to get to that I find very effective for trying out different ideas is to simply put in these green lines, put in 2 sets, and rotate them until they do what I want. Now, this is the sort of thing that you can see how easy that would be with a base mat and 2 sheets of trace paper, and those 2 sheets of trace paper each have one set of green lines on them. So I can rotate those as much as I want. You also remember from a minute ago that if this is the ridge, then our contour lines can bend at that ridge. Does this seem familiar? Yep, we've done it a couple of times. And notice when I'm talking about the slope, I'm talking about the slope of the parking lot. I'm not talking about the slope of the ridge line. I really don't care about the slope of the ridge line. I care about the slope of the parking lot. And then perhaps I put my swale here. So now we have slope running away from the building. Let's put that in pink. On both sides, we have slope running this direction across the parking. And we have a swale running water out on both sides. So I think this concept has been explained sufficiently at this point, but we will always have the chance to come back to this. So once we have these laid out, we can then draw in the contours, and those contours are only going across the parking lot. You notice that I pretty much trimmed them after I got off the pavement. So once I got off the pavement, we kind of trimmed them. So we have those lines now. And once we have those lines, we can take the grid away. Those lines represent 1 foot contours. What we have not determined yet is what the elevation of those contours are. And we have not determined what the finished floor elevation for the building is. And that is okay. That's a change for you guys. We have always given you a finished floor elevation or made you establish a finished floor elevation. But in this case, we're going to establish the grading and then determine what finished floor elevation works well. As you recall, when we had this example up, we started to run lines across this. And when I did that, I didn't tell you what the elevation of those lines were. But I simply said, okay, let's connect those in. And then Sandeep said, okay, what about drainage? Okay, that's cool. So we just started connecting them in. Because where they should connect seemed very obvious to us as we looked at this. But we could have changed that. We could have said, no, we're going to connect this one in up here. And then this one's going to come down and go up. And this one's going to come down. You see how that changes the design? So I changed which one we connected to. So this process, the question is this possible use for only parking lots, or can it be used in grading residential properties? It absolutely can be used in grading residential properties, but you have to understand spacing contours before you can do pushing contours. So yes, this process could definitely be used last semester. But what I want you to understand is once we have those contours going across the parking lot, we can then say, oh, what's the easiest place to connect them in? And look, this system works. That's kind of cool. If we take that out and we say, all right, we were going to connect this down here before. Remember, we did that every time. But now what if someone said, oh no, you got to connect it down there. And now you got to take this up and around and connect it into there. Well, now we got a drainage problem, but that's okay. What if we find a way to do that? Go way up here and then come back with some sort of a swale back to there. And now this one is going to connect down to here, and this one has to connect down to here. And so through process of pushing contours, you will discover, I think I cheated there. this one down to here, down to here. You will discover what works well and what doesn't work well through pushing these contours. Does that make sense? So we just did 3 different solutions on this little parking lot. Now we're going to go back and see how that is done on the large plan. So now we're back to this large plan. One of the things I always have to do is I have to add numbers so I can see what the heck is going on. So let me add some numbers. And so all we did here is we went in and we labeled where the contours hit the vegetation on this side. And then we just said, okay, and then we'll just go down here. Then we came over here and we labeled where the contours hit the vegetation. And over here, we just picked an area that we didn't want to go into that swale over there. So there's nothing magical about the fact that I chose, this line and that line, except that they're far enough out that I'd like to be back. And over here, you're thinking, okay, why didn't you do that? Well, because frankly, this 0 goes over and connects. And so I may have to work in there, but I'm not going to worry about it yet. So I always go in and I label these contours, and you will notice all I did was label the index contours, the 5th contours. Once I have those labeled, I can start to try to connect in these contours to the yellow ones I have on the plan. But the first challenge you will have is like, all right, give me a hint. How do I connect them? What numbers should these contours be? And so I'm going to ask you a question based upon your previous grading experience. Where do you start? You have to run through the lectures in your mind. And I'll give you a hint. You start with the least flexible element. What is the least flexible element that you have to hit? You have to match up. Where the entry drive meets the road. Yes, where the entry drive meets the road. No, it's not the building, because we're going to come back to that in a little bit. So right up here, we have to be able to make that connection. So if we have to make that connection, we're just going to go in and take a look at that and see what we got. Let's see, this is the 10 contour. So let me draw in the 10. This is, come here, Muska. This is the 10 contour. This is the 11 contour. This is the 12 contour. This is the 13 contour. It kind of comes over and pops out like this. Huh. Well, you know what? I'm going to make a guess. You want to go with 12 or 13? Which do you prefer? By the way, this area over here, you're allowed to grade onto. We're Penn State, we own everything. So if you want to move these contours over here, you are allowed to do that. Which means I can move all of these over to there. Which means I have some flexibility up here. So which one you want to start with? You want to start with 10, 11, 12, or 13? All right, so 12, that is this contour right here. So we're going to take that contour and we're going to connect it in. Excuse me. And let's see. This is the 14, 13, 12, I believe. So it's going to connect in right there. So that is the 12. That means we're going to take the 11. We're going to go down here with the 11, and we're going to connect it in here. Okay, but now it goes back into this area. Maybe that'll be a problem, maybe not, because with the 11 also is in the trees here, but let's just keep playing. We'll take 10, we'll change its color, and we'll take 10 and we'll connect it in there. And then we'll go back and keep connecting in. This is number 9. This is number 8. This is number 7. This is number 6. And then we're going to label it so we remember that is 6, 7, 8. And if you dare submit something for us to review that is not labeled with contours, we will give it back to you. You must always label your contours, even if you're labeling it with a mouse. Okay, so we can see that this side works. Agreed? Okay, you know, here's the original 5. It might have to push out some and then go over and connect in. And maybe the 4 will have to push out some. Maybe the 3, maybe the 2, maybe the 1. But that's going. This is the 6 coming all the way across. It's going to now reverse. Wow, that was ugly. And then it's going to attach in where? Well, it's not going to attach in over here, is it? So it's going to come around, it's going to hit the building. And then it's going to come off the building over here, because that's still the 6. So in other words, that 6 is actually running around the face of the building, coming off over here. And then we're going to see if it can connect in on the other side. So I have to zoom out, which means I'm going to lose my marks, but that's okay. We will do it again, and we will remember that the one right above the building is the 6. So you will see that as soon as I zoom out, none of that works, so we clear it, and that's fine. We'll zoom back in a little bit, and now we're going to go back and play. So this is the 6 coming across here. Here, it runs around the building. Here, it just hits the building. Then it goes up this way, and in some way, magically, it connects up here, and we've already done that, so we're not going to do it again. Now we're going to say, okay, that's 6. It has to go over here, connect. Excuse me, I'm about to lose my voice. If that's the 6, this is the 7, this is the 8, 9, 10, 11, 12. Now that's 7. That 7 can come in and connect down here. That 8 can come in and connect down here, but we're starting to see some issues. Here's the 10 and here's the other 10. That means that the 9 could come down and connect and the 10 could come down and connect, but we're actually pushing water really close to the building, really close to the pavement there. You don't have to worry about that yet, but I'm going to show you so that you don't get messed up on this. It could be that we want our 10 to start to create a swale. Nine, 8, 7. And this gets to be a little challenge because now we got to figure out how we're going to fit that 11 in, but it'll go. Okay. Now I'm going to zoom in again, which means you're going to lose those lines, but that's okay because we're going to go after it again. You will note that if this is the 10, 11, 12, this is a 13. That 13 can actually close on itself right there. And that 13 can actually close on itself right here too. Why do we want to do that? Well, let's see. This is 6, 7, 8, 9, 10. And we said we wanted to, oh, that was an interesting 10, wasn't it? 10. And we said we wanted to create a swale with this 10. And that swale is going to come all the way down here and connect into the 10, which means the 11 is going to come all the way down here and connect into the 11. Wow. And at 12, we've got a couple of choices with the 12. Because this is the current 12 running through the vegetation. You with me? So we have two options with that 12. One is we do the exact same thing as we did before with the 13, and we connect the 12 this way. Then we take this 12 and we simply connect it over here. So this is 11 and this is 12. 7 is going, see, 9 is going down below the 10. 8 is going down below the 9. 7 is going down below blah, 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 blah. You guys are starting to get the picture here. Over here, we're probably going to have a 5 coming up. Whoa, that was poorly done. A 5 coming up that turns and connects into the building. And we'll have a 4 connecting into the building, and a 3, and a 2, and a 1. And we're going to slope them away from the building if I can get my mouse to cooperate. And how far down are we going to have to go? Well, if this is a 6, what is a reasonable FFE for our building? So if this is a 6.5, so 6.5, wow, that's horrible. That means that down here at the bottom, our elevation is going to be, say, 96. Because this is actually a 100 and 0. It's actually an 1100 and 0, but that's not the point right now. Down here, we have to be 10 feet below. So there need to be 10 of these contours, including this one up here, that hit the building in order to get 10 feet below. Hold that thought, because that brings up the next important issue. And that is, if we're at the top of the building, and at the top of the building, this is 6, and the building itself is 6.5, then at the bottom, we're going to have to be 96. Guys, understand there are some extra zeros in there that we've left out. So if that's going to be 96, that means that the 96 contour, which is right here, needs to go below our building. Man, you guys just got way too lucky today. And all these other contours are going to come in and hit the side of our building. That's a lot of contours. And even the 6 contour is going to hit the side of the building. I think that is more than enough to get you guys started on this. Because if you're not kind of freaking out already, there's something wrong with you. But it's actually a fairly simple process once you have done it. So let's run back through, because I want to make sure you guys get this. Okay, we're going to start out at the top. We're going to recognize that there is a ridge line that's available to us if we want to use it. And we can actually move that ridge line to make it available to us. The ridge line does not have to be straight. It could be curved. It could have a bend in it. But for where you guys are in your development right now, straight would probably be best. You're then going to lay out 2 sets of 1-foot contours that are 50 feet apart or 40 feet apart. Some find it much easier to go with the 40 feet. You're going to then rotate those contours so they fit your design in terms of the contours a little better. You're then going to lay out and concept for how you're going to run those contours across those paved areas. You're going to get the green lines out of your way. You're going to label the contours so you can find the little fellas. And then you're going to start connecting them, and you're going to start at the road. And you've got choices at the road, but you're going to start at the road. You can try 11, you can try 10, you can try 12, 13, 14, whatever you want. The nice thing is it's not that hard to do it 2 or 3 times. So in other words, if you just go through and label, each of these contours with a number and then see if they'll connect, that's fine. You also do not have to make the bend right next to the building up here. You could just as easily say, no, I want it to be back here. And then this contour will simply be like this and run around the building. All of these are options that are available to you. And what's most important, to be truthful, is that you try more than one. You absolutely have to be prepared to try more than one. You also need to be prepared for us to come back to your design and say, oh, that's nice. Why don't you try moving that swale back out further to the parking lot? And you're not going to vomit because you're going to say, yeah, I know how to do that. I'm just going to turn and redo a few of these. You also might find that we might come to you and say, hey, why don't you change that slope on that parking lot? And you're not going to quit your job. You're going to say, okay, I'm going to try a different slope on that parking lot. What would you like me to try? And, if you've got it at 2%, we'll say, try it at 3. If you've got it at 3, we'll say, try it at 2. This is normal in an office. And we need you to become more confident through this process. And that's the way you become more confident, is by doing this process so that you're not so afraid of making changes. Okay, that is our set of lectures for today. I know it's a lot to dump on you in one day, but I wanted you to see where we are going.